In the summer of 1972, a young man named Bhargava, just shy of turning 2 years old, sat on the floor of his grandmother's home in Jaipur, India, stacking mangoes into a pyramid. His grandmother, a Sanskrit scholar, was reciting ancient Indian poetry. Bhargava wouldn't understand the deeper implications of either the mango stacking or the verses for years, but both would seed a lifelong fascination with a single question. What is mathematics? Really fast forward 30 years. And Bhargava, now a Princeton professor and Fields Medal-winning mathematician, still wrestled with the same riddle that captivated thinkers from Plato to Einstein. Is mathematics something we invent? A language of symbols and logic constructed by humans? Or do we discover it? An eternal truth woven into the fabric of the universe, waiting to be uncovered. To answer this, we must travel through time, across continents, and into the minds of history's greatest thinkers. Let's start in ancient Greece. In 387 BCE, Plato founded the Academy, inscribing above its door, "Let no one ignorant of geometry enter here." To Plato, mathematics was not merely a tool, it was the key to understanding the cosmos. He believed in a realm of perfect forms, an invisible world of truths. The number pi, the Pythagorean theorem, the square root of 2, these were not inventions, Plato insisted. They existed independent of humans. Mathematicians were simply discovering what had always been there. This belief has persisted. In 1900, the German mathematician David Hilbert proposed a list of 23 unsolved problems, declaring confidence that all could eventually be solved with pure reason. He saw math as a grand landscape waiting to be charted, like explorers mapping new continents. But then came Gödel. In 1931, Kurt Gödel, a shy Austrian logician with deep-set eyes and an obsession with infinity, shook the mathematical world with his incompleteness theorems. He proved that in any consistent system of arithmetic, there would be statements that are true but unprovable. Let that sink in. Gödel showed that no matter how many mathematical truths we think we've uncovered, there will always be truths beyond our reach. If math were a physical territory, it had no edges. It was a fog-shrouded landscape with infinite blind spots. It was the mathematical equivalent of discovering that some doors will always remain locked even if you have the master key. This raised a disturbing possibility. Maybe mathematics isn't so much a discovery as it is a creation. Maybe we build systems that work for us but can never fully capture all truths. Maybe math is invented. Let's leave the ivory towers and enter the trenches of history. In the 9th century, a Persian scholar named Al-Khwarizmi developed algebra, a term that comes from the Arabic al-jaba, meaning reunion of broken parts. His algorithms were invented to solve real-world problems in inheritance, trade, and architecture. Centuries later, calculus was invented almost simultaneously by Isaac Newton in England and Gottfried Wilhelm Leibniz in Germany. Both men created their own notations and methods to describe motion and change. Their work, though based on observations of nature, used rules and symbols no one had seen before. And then there's the case of imaginary numbers, like the square root of -1. No one discovered these in nature. You can't pull root -1 out of a hat or a tree. Mathematicians invented them to solve equations that otherwise had no solution. As Richard Feynman, the Nobel Prize-winning physicist, once said, "Mathematics is not real, but it feels real." Where is that placed now? Back to Bhargava. As a student at Harvard in the 1990s, he returned to the childhood memory of stacking mangoes. Inspired by the ancient Sanskrit poetry called shlokas and their rhythmic patterns, he uncovered new insights in number theory using composition laws that had been lying dormant for 200 years, since the time of Carl Friedrich Gauss. Bhargava's work was hailed as groundbreaking. But he hadn't just invented something new. He had also discovered hidden connections buried in ancient texts and old formulas. It was as if the math had always been there, waiting to be seen, but only through a lens crafted by human imagination. When asked whether he thought math was invented or discovered, Bhargava answered, "It feels like both." So what's the answer? When NASA sends spacecraft into deep space, they encode data using mathematics. Prime numbers, binary patterns, geometric diagrams. They assume that any intelligent life, anywhere in the universe, would recognize these forms, not because we invented them, but because they are universal truths. And yet, ask a historian, and they'll point out that different cultures invented different systems of counting, geometry, and logic. The Mayans had a base 20 system. The Babylonians used base 60. Even the concept of zero was a breakthrough that took centuries to be discovered or invented, depending on how you see it. Here's one way to think about it. Mathematics as a mirror. It reflects the truths of the universe. The orbit of planets, the spiral of galaxies, the structure of DNA all follow mathematical patterns. These we discover. Mathematics as a map. It's a tool we draw ourselves to navigate the world. We choose the symbols, the language, the systems. These we invent. In 2006, a neuroscientist conducted an fMRI scan of a mathematician solving a problem. The brain areas that lit up were the same as those activated by music. Why? Because math, like music, is both abstract and structured. Both have rules, and yet both allow infinite creativity. You don't discover Beethoven's Ninth Symphony, but you don't entirely invent it either. You compose it, guided by rules, inspired by patterns, bounded only by imagination. Perhaps the question isn't whether math is invented or discovered. Perhaps it's something in between, like a melody you hear faintly in the distance. It already exists in some sense, but you must still give it form. You must listen carefully and then compose. Years later, Bhargava still speaks of mangoes and Sanskrit poetry with affection, not because they answered the question, but because they framed it. As you leave today with this story in mind, ask yourself, when you count the stars, solve a puzzle, or marvel at a snowflake, are you inventing patterns or simply discovering what was always there? If you found this helpful, hit that like button, subscribe for more amazing content.